In this lesson, we will walk through the answer to the optional test problem for our Intro to Fields course. You began with a starter file that had our geometry, which was this nTop tag, and you had a CAD inner body, the outer body, and then CAD and topology, our name, as well as this CAD faces for ramp, which you can use as one of your options for your scalar field in your field-driven design and ramping. So after we had the geometry in this starter file, the lattice was already created, which uses a branched lattice body. And we have it going through our inner body, we have these holes that we'll create using that branched lattice body. And the final part is our lattice inner, which is just a Boolean subtract of the holes from that inner body. And then we do a Boolean union of that latticed inner, the topology name, and the outer body. So this is what we were given with originally, with a hole thickness that is uniform. In order to have some type of varying hole thickness, we can use our ramps and field-driven design, which we've talked about in the previous lessons of this course. So I have this field-driven design section, which we'll use to change the thickness of these holes. The first task was to use the nTopology name to drive these designs. So I have this hole thickness as a variable, so I'll just drag and drop that body ramp and we'll see what that looks like. And what this does is I have that nTopology logo as that scalar field. I'll type F so we can see what that ramp looks like. And I'll actually turn off that final body. And what we can see, if I probe my values, is that at that nTopology logo, we'll have that outmin of 1 millimeter. That's the thickness of our holes. And it'll increase to 3 millimeters. And the inmin and inmax is that starting location and that end location for some type of change. And the thickness changes from 1 millimeter to 3 millimeters. So you might have a slightly different result, but something like this, where you have those smaller holes around the name and then the larger holes as you get farther away, should look similar to your piece. The second option we asked to do was to use instead 3 points to create this design. So to show that final result, I'll drag and drop that point ramp variable, and that will apply this to my final body. And I'll also show these points, which are highlighted in blue. So I have these 3 points, and we can only have one scalar field in this ramp. So I do a Boolean union to take these 3 points and make them into one scalar field, which if we look at that, I'll add a contour interval of 1. Let me show that. We have those circles around the 3 points, and it's going larger and larger. So this is the field that we're using as our reference. And when we're 2 millimeters away from those points, we'll start seeing that change and end that change 30 millimeters away. So if I type F to view that, we can see if I probe my values, we start with about 1, and then we go out to 3 millimeters. And that's what we see in this final body as well too. So you have those smaller holes when we're closer to the point, and they're getting larger as we're farther away. And you get a design like this. The last ask was to use that CAD faces for ramp that we have in our geometry section. So that would be these faces. And because it's more than just one face, we're going to convert this to an implicit body, so we have that field to work with, but we also need to stitch them so we don't have multiple fields to work with. So first I use that stitch adjacent CAD faces. So it looks pretty much the same, but now they're acting as if one CAD face. And then we convert this to an implicit body. If we type F, we now have this field. I'll make this size a little bit larger. And if I probe my values, we can see that anywhere going kind of outside of that face is going to be negative, inside the face is positive. And the reason for this is because our CAD face that we chose is using that face inside that hole that we have. So anywhere that's on that kind of opposite side of the face is going to be negative. So a little tricky with this example is instead of using our in-min and in-max from 0 to 80, we're going to have this 0 to negative 80 because where we want to see that change, which is outside of that hole, is going to be all negative. So let me place that face's ramp into that whole thickness and view this final body. And we can also turn on that field for the face's ramp. Let me type F. And let's make our contour interval, let's do 0.5. If we probe our values, we're going to go from 0.5 and then increase as we go farther along to 3.5. And you can see that in this whole sizes as well too. So those are 3 examples of when you might use our ramp to drive something like that beam thickness in this problem.